Alright guys, as you can see, we're going to be working on adding and subtracting polynomials today. It's very similar to adding and subtracting regular numbers. The biggest thing is that you have to make sure that you keep things that are the same together. And what I mean by that is we're paying attention a little bit to exponents again now. Both the base and the exponent have to be the same to add or subtract them. So, what we're going to do if we're adding and subtracting is we're going to put the same with the same. So we're going to pay attention here to that x to the third. That x to the third there goes with this x to the third here. I look at this x here. I don't have another x on there, so it can't go with anything. I look at my x squared right there. And then I look at my constants here. Now, the trick to this is that realizing that even though it's not highlighted, that those coefficients go together, that is just constants. That coefficient is going to be going with that x squared. And then when I look at this x over here, that -4 is going to go with it. What this means when I'm looking at this, that 2x to the third means that if I have x to the thirds in a basket, I've got two of them. I need to put them in a basket with other x to the thirds. Well, this basket over here has -3x to the third. So what I'm going to do to make this a little easier on myself is I'm going to line them up like I was adding a column of numbers. Now, if I was adding a column of numbers, let's say I had 234 plus 175, I'm going to line those up, one on top of the other. And what I'm going to do is I'm going to match up hundreds place with hundreds place, tens place with tens place, and ones with ones. And when I do that, I'm going to stack them, and I have 234 over 175 to add those. They get all lined up. We're going to do a similar thing with our polynomials here. So let me take a second to get rid of this mess here. And we're going to rewrite these polynomials to line them up. So I'm going to start with my top here, 2x to the third. And I'm going to go ahead and line up under it as I'm writing other things that go with it. So in this case, that -3x to the third is going to go underneath it. So -3x to the third. Now, because when I write it, it's going to need to be in order anyway, because if you remember, standard form writes polynomials in order from least to greatest. So I need to look for my next biggest exponent, which is a 2 over here. So it's on the bottom, so I'm going to leave it on the bottom, plus 2x, but if you squared. But you notice I don't have any other x squareds from my other problem over here, so I'm going to leave that spot blank. If you would like to put a 0 placeholder, you can. Some people like to do that. What I mean by that is put a +0 up there because I don't have any x squareds. Don't have to do that. You can leave it a blank. Either one works, whichever one helps your brain process it. Next, I'm going to go to my x's. And you notice I've only got the x here. So I'm going to put it up here. That's -4x. I don't have one on the other, so I'm going to leave its spot blank. Or again, if you need to, you can write +0 as a placeholder. Okay? Not required, but if that helps your brain process it, go for it. And then my last, I have my constants, -6 and 5. -6 is with my top number, so I'm going to put -6. +5 is with my bottom number, so I'm going to put +5. I'm going to draw my column underneath and remember that I'm adding out front. Okay? Now, what that does is that helps me keep all this straight. And when I drop that down, it's going to stay in the column it's supposed to be in. Now, what I have to pay attention to here are these coefficients, these numbers out front. I'm now adding 2 plus negative 3. If you punch that in your calculator, 2 plus negative 3 gives you negative 1. My exponent and my base do not change at all. I leave them just like they are. So it comes down x to the third. My next one, 2x squared. I don't have anything to change it, so it's just going to come straight down just like it is, plus 2x squared. I go to my next term, negative 4x. I don't have anything to change it down here, so it's going to come straight down. Negative 4x. I go to my next set of terms, negative 6 plus positive 5. I'm going to add that, I get negative 1. So as I'm rewriting that down here, give myself a little more room to write there. As I rewrite this answer now, I'm going to have negative x cubed, and the reason I didn't write the 1 out front is because I don't need it. 1 times a number is just that number. So that's negative x cubed plus 2x squared minus 4x minus 1. This right here is my final answer. That's what I would write down for that problem as my answer if I simplified that. Generally, instructions come with simplify or simplify the polynomial or add and subtract the polynomial. Generally, your directions will say something like simplify. And if it says simplify, that's what I'm going to put for my answer. So let's try another one. There we go. There's our last slide. And when that happens, that keeps you from having to reorder it later. It's not wrong if you do that. You know, it's just a little extra work for you. So I've got this problem here. 5x squared plus 2x minus 1 plus 3x squared plus 5x plus 2. And all adding and subtracting polynomials is combining like terms. You've done this before. You just didn't know it was called adding and subtracting polynomials. And that's all it is. To do that, as I said, I generally have people line it up to make it a little easier for them. That's not required. If you're able to see 5x squared, 3x squared, and add those together and write down your answer, that is something you're allowed to do. I find especially when we're subtracting that we have a tendency to make mistakes if we're not careful. So that's why I recommend lining it up. So as we line that up, we're going to put same with same. We're going to go ahead and look, 5x squared, we got another x squared. That's our biggest term there. We're going to go ahead and write that down. So 5x squared, 3x squared. And I recommend doing it one term at a time in case you come across. We're jumping back to the slide we were on, taking it one piece at a time. We're going to continue with our next biggest term, which is x. So we're going to take that and go ahead and write that. We've got 2x on top plus, the sign always goes with it, plus 5x on the bottom. And then last, we have our coefficients, our constants on this, not coefficients, our constants, which is not minus 1 or negative 1, if you want to think of it that way, plus 2. You don't have to do it this way. Like I said, it just helps prevent mistakes and helps you keep from reordering it later. So now I look, 5 plus 3, that's all I'm looking at. 5 plus 3 is going to give me 8. The x squared doesn't change, it comes straight down. Then I'm looking at positive 2 plus positive 5. So plus 7x. The x doesn't change at all. Then I'm looking at negative 1 plus 2. So we've got positive 1 down here. This is my answer. I don't have to do anything else. I don't need to try to combine anything else because nothing else will combine. I have to keep the same thing with other things just like it. We're sorting and putting it all together. It's what we're doing. So, let's look at one more example before we move on. So I went ahead and color-coded these where they match, save us a little time there. So x squared with x, constant with constant, etc. So we're going to go ahead and line those up. 5x squared lines up with 2x squared because those are the same. Plus 2x minus 2x plus 3 plus 5. And again, if you can match as you're going across x squared with x squared and do that total, x with x and do that total, 3 with 5 and do that total, that's fine. Go ahead and do that. That's allowed. This just helps prevent some mistakes, especially when we get to subtracting. So, adding. We're going to add those, just the front numbers. 5 plus 2 gives us 7. The x squared doesn't change, so x squared. Positive 2x plus negative 2x. So 2 plus negative 2 gives me 0. Three plus 5 gives me 8. Now, what's important here is to realize that 0 times anything is 0, that what happens when I have 0x is that term goes away. It's not there anymore. So when I rewrite this as my final answer, I'm going to have 7x squared plus 8. And that's it. That x term goes away. It cancels out right up here because of that positive and negative there. All right? So there's addition. And what happens is you've got a worksheet. Looks something like this. And as you go to do this worksheet, you've got your addition problems down here at the bottom. Again, I recommend lining those up one piece at a time. And they did the first one for you. Move that just a little bit. They did the first one for you here. So they added the one across, negative 3x squared plus 16x, and got 13x squared. They added 14x and negative 19x and got negative 5x. Now if you notice, negative got its own box, the 5x got its own box. Then they did negative 11 plus 3, so it got negative 8. And you notice that the negative got its own box and the 8 got its own box. Puzzle up here is worth 3 points only. I need to see your work. It needs to be on a separate sheet of paper. Okay? Put your work on it. I need to see where you added those numbers and got an answer. I don't want it just filled in up here. If you fill it in, great. If you don't fill it in, that's fine too. It's just going to cost you 3 points. All right? So that's addition. If you want to do that first and then come back to the second half of this video, go for it. Otherwise, I'm going to move on to subtraction now. Before you move on, do make sure you understand this. Feel free to do some practice problems because subtraction is basically the same but tends to trip people up a little more. So make sure you've got a good handle on addition. Feel free to stop this, rewind it, whatever you need to do, and then feel free to come back to subtraction in just a minute. Don't skip the subtraction part. So as I said, the subtraction part here is mostly the same, but because it's subtraction, we've got to pay attention to more stuff. So I'm going to go ahead and color code these here. You got x cubed. I don't have any other x cubes. I've got an x squared. I don't have any other x squareds. I've got an x, and I've got another x to go with it. And then I have a constant and another constant. Now, obviously, you don't have to color code yours, but if that's something that helps you, feel free to do that. But you're going to have to get used to looking for those coefficients to match that up. So before I do anything, I need to realize that I am subtracting. That means all of this one over here is being taken away from the first one. So that means I am subtracting negative 7. If I'm subtracting a negative, if you remember, that's like adding. Okay? I'm going to show you the way we did it before, what that looks like, but I'm also going to show you another way, and it depends on which way your brain works with best, depends on which one you should do. But you need to remember, because you're subtracting a negative, That's going to wind up being like adding. That's subtracting a negative. That's subtracting a positive, so that'll just be normal subtraction, taking away 3. Okay? So let's go ahead and line this up. I'm going to start with 9x cubed. I don't have another x cubed, so if I want to go ahead and put a 0 placeholder, that's allowed. Now my next, because subtraction order matters, it really is important that we get the first ones on the top, get our first set on the top and our second set on the bottom, and not to get those mixed up. So the next one I've got is negative 7x squared, but I don't have an x squared in the other one, so if you want to have a 0 placeholder, go for it. Then I'm going to go to my x terms. So I've got plus 5x for my top, minus 4x for the bottom, and then I do my constants. So I've got negative 7 on top and positive 3 on the bottom. It is really, really, really important that you make sure that the second one goes underneath if you're using this method. It is extremely important. So now we're going to put that subtraction sign out front and our tally bar underneath so we don't forget that we're subtracting. So now what we have 9x cubed minus 0. So if I don't change anything, that's just 9x cubed. All right? Now, I have 0 minus negative 7. Now, if you're bad with subtracting negatives, type in your calculator 0 minus negative 7. 0 minus negative 7. You're going to get positive 7. And again, my x squared doesn't change. My next set, I have 5 minus negative 4. So that's 5 minus negative 4. That's going to give me positive 9x. You see where it's real easy to get confused on there if you're not remembering that you're subtracting a negative number? Subtraction is the hardest one. Then you've got negative 7 minus 3. So that's negative 7 minus 3. And that's going to give me negative 10. Now that is going to be my final answer there. That doesn't change at all. But you need to be aware when you're subtracting which one you're subtracting. So that's 0 minus negative 7. If, and this is especially important with that 0 placeholder, and why it's a good idea if you struggle with that kind of thing to remember, because what's going to happen is you're going to have 0 minus positive 7 on another one. I'm going to do that on my next example. If you have 0 minus a positive here, this answer is going to be down here is going to be negative. That's going to seem very confusing to you. So let's actually look at an example like that. All right. So already we can tell by looking at this one that we don't have the same number of terms. So it's not going to line up perfectly. It might help you again if you're a color coder to match those up, but you're eventually going to have to get to where you're just looking at those exponents. So if you need to underline or something to begin with to help you, but as you do more and more of these, it's going to get easier. So we're going to start by lining this up. The first one always goes on top. So I've got 3x squared. I've got another x squared in my other set. So I'm going to put negative 2x squared because I always keep the sign with it. It gets those gone. I'm going to go to my next biggest term, which on this one's the x. Now, I notice it's in the second term, so it's going to stay on the bottom. So plus 2x. And then I put my constants. I put a 0 placeholder. It would probably be helpful for you if you do this. Negative 3, positive 4. And everything's all lined up. I'm going to put my subtraction sign out front so that I remember I'm subtracting. Okay? So this is 3 minus negative 2x. So 3 minus negative 2, 3 minus negative 2 is going to give me positive 5, and my x squared doesn't change. Now for my next one, I have 0 minus 2. So again, that's going to be 0 minus 2. So that's going to give me negative 2 x. My next one, I'm going to have negative 3 minus 4. So we have negative 3 minus 4. And that's going to give me negative 7. And that's my final answer on that one. You see how subtracting adds a little bit different, one more piece that you've got to pay attention to. And this one really messes people up. That sign change right there really messes with people. I need you to be extra, extra, extra careful when you're subtracting. Okay? It is extremely important that you are extra careful when subtracting, or you will get it wrong. And as a matter of fact, that's probably the number one cause for people getting these wrong, is that they're subtracting and don't pay close attention to their signs. All right? I'm going to show you the other way, as I promised. If you like this way, you can ignore the other way, but you might want to at least look at it. That way you can compare fairly and see if you actually like this one the best. All right, so our other method will allow us to use addition, which people have a tendency to do a better job with. I don't know why addition is easy and subtraction is hard, other than subtraction order matters and not everybody pays attention to that. So the way we turn this into an addition problem is we take this subtraction sign here and treat it like a negative. We pretend there's a 1 there, because there's an imaginary 1 there, and we distribute that negative 1 to the second set of parentheses. Now, only that set of parentheses. People start wanting to try to multiply it by the front, and that does not work. You will mess up every single time. Don't do that. So remember, only distribute to that second one. Now, all this is, and you don't have to remember to distribute the negative 1 part. What you have to remember is this changes this sign. It changes all of these other signs as well. So I'm going to rewrite the whole thing as it looks. So the beginning doesn't change. 9x squared plus 2x minus 1. That doesn't change at all. But now we have plus parentheses. That's not a positive 3x anymore. It's now a negative 3x squared. That's not a positive 5x anymore. That's a negative 5x. And that's not a negative 7 anymore. It's a positive 7. Now, this method has the advantage of allowing you to add, which really cuts down on the number of sign mistakes we make when we're doing the actual combining. The downside to this one is that people mess up this part right here in distributing that negative and changing all the signs. Now, you may be used to seeing something like that before already, and if you are, then great, use it. I have people come in that they said that their 7th or 8th grade teacher taught them a trick like that they can distribute a negative and add. And if you've got that and you're used to it, feel free to use it. If you saw that one and that made more sense and you're going, good, I'd rather add than subtract negative numbers, then use that one. It's really helpful. As I said, the biggest disadvantage is that people don't change the signs right. 2 most common mistakes is they forget to change this and still try to subtract. Or they don't change that front sign. Okay? The next most common mistake, I'd say almost tied for number 2 there, but our third mistake is that they won't change these. They'll remember to change the minus, they'll remember to change the first one, but then forget that they have to change these as well. So you've got to be careful with that. Realize where it is, what's going on there, and really be careful, because that's the biggest thing with subtraction, is being careful. Now, this is what your class work looks like. It's very similar to what I've just done there. Sometimes terms are eliminated, sometimes they're not. But overall, subtracting, going through, the biggest thing you have to be careful about is watching those signs. If I'm subtracting a negative, remember that it's like adding. If I'm distributing that negative all the way through, I have to remember to change all the signs. If you will remember, the puzzle down here is worth 3 points. If you do not show me your work, you will only get 3 points credit. Now, for those of you that have gotten a 3 on one of these puzzle papers, you know I'm not kidding. Okay, so show your work. Yes, I'm going to make you write all of these out and show your work. Even if you can do it in your head, even if you can do it on your calculator, yes, I am making you write it all down. Get used to writing things down because this unit requires lots of writing, okay? You had an easy unit as a break. Get ready for one with lots of writing, okay? You have this paper to finish. You've got your hour-and-a-half class to do so. You've also got one more thing to go, and it looks like this. It's only a couple problems, but it's both addition and subtraction, so you need to pay attention to the sign. The very first thing you should do as you're doing this is check your sign. Plus, 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 minus, 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 minus. You need to pay attention to what you're doing. Every single time I have somebody go along and they add, and then they don't pay attention and continue adding, okay? Now, I know this one looks a little messed up, and it's because it didn't load well on my page here, but yours looks nicer than this. So, all that's due tomorrow. I will come in this afternoon and pick those up and start looking at them. Feel free to turn them in if you finish them. Take them and finish them elsewhere if you don't finish them. If you are really struggling and need help, send me an email, or realize that every single math teacher in this department has Smart Lunch B today and will gladly answer any questions you have. Okay? So feel free to go in there and ask if you need to, but as I said, as I promised, it's fairly straightforward. The hardest part is paying attention to your signs on subtraction. All right? Well, I'll talk to you guys via video again tomorrow. And feel free to email me if you have any questions.